Welcome to Lesson 5 of Chapter 10, Advanced Swift with Bob Developer. Throughout the course, I mentioned the microwave analogy that things simply work because someone else had designed the microwave. We press a couple buttons and start working. We don't really have to understand how the microwave works internally as a user. However, we don't live in an ideal world. Sometimes, what if you have to create your own microwave? Then you got to know everything about the microwave. In this lesson, let's really find out what goes under the hood of a for and loop. What makes it possible? Well, it has to do with protocol. Welcome to Chapter 10, Advanced Swift, Sequence and Iterator Protocol. Today, let's talk about what goes under the hood of for and loop. We talked about before, sequence allow you to have a for and loop, right? Well, let's talk about what goes underneath the hood, okay? So this is what we're taking for granted since, 1 second. We've been taking for granted, so we've just used it for fun, just like that. iOS skills, Swift, UI kit, reactive test stream development, and you're able to use this for and loop to do that. But you might be thinking, what's really happening underneath? How does it even work? Well, are you wondering right now? Well, there's also you can apply to Bob Developer, convert it to characters, and then you can add that for and loop as well. You have Bob Developer on the left side, and in fact, you don't even need to convert it to characters. You can also just now in Swift 4, string confirms the sequence protocol that you can go through this part like that. Okay, so I said many times before that if anything that confirms the sequence protocol allow you to do a for and loop, but what's really happening underneath? Well, there's a two-step process behind the scene when you use a for and loop. So, as you know, programming language Swift is nothing more than a language that allows us humans to understand easier, right? And what happens is it gets converted into something different semantics. So what's happening is like this is happening. So we have a iOS skills array, right? And then this thing array confirms the sequence protocol. How do I know this? Well, just go here, take a look at definition, click on it, sequence, type sequence. You will see a lot of sequence up there. Yeah, it does confirm the sequence protocol. If you don't believe me, you can go to documentation and just take out the what do you call that? The hierarchy. Okay, you will see that array confirms the sequence protocol. So anything that confirms the sequence protocol contains this method, make iterator. Okay, this method returns some sort of an object, and then the object, I'm going to call this as a skill iterator, and then this object also contains a required, also confirms to a protocol called iterator protocol. So now, array confirms to a sequence protocol, and then if it confirms the sequence protocol, it returns, it has a method called make iterator. I'm going to talk about it slowly. I'm going to go into the documentation later, but I just want to walk you through the basics first. Has this method called make iterator, and then this method returns an object that confirms to iterator protocol. I'm going to take a look at it, the documentation soon, but just bear with me for a second, 30 seconds. And you're able to have this while let skill. This is one way to unwrap it, continuously until it hits nil value. So skill iterator.next, what it does is when you call this .next method, what's happening is, for example, when you have an array number, and then let's say this is a number iterator, numbers.make iterator again. This is an array, so it confirms that sequence protocol has this method available, and then this number iterator confirms it to protocol iterator protocol, and then has a method called number iterator.next. Okay, you can continuously call it. So what's happening is this method will call the number 2 and then call number 3, number 5, number 7. But if you take a look at it, it returns an optional type, int value, because what's happening is when you go all the way to number 7, and here it becomes nil on the right side, right? So anything that comes after is going to be nil. So what's while that is happening is it's unwrapping. You unwrap it until continuously call this function until you hit nil. That's what's happening underneath a for and loop. Okay, this semantics is converting to this way right there, and then it is turned into a machine code. Okay, so you understand what's going on with the for loop in the front. But now let's talk about the behind scene. So what makes a thing conforms to a sequence protocol? Well, let's take a look at it. Let's go to just type sequence, okay, and then go here, public protocol sequence, okay. And then what's happening is it has a method called make iterator, and what's happening, it returns self.iterator. What is self.iterator? Well, self is the object that conforms to that protocol, right? And it has a thing called iterator. It doesn't really, we're not sure if it's a method or it should be a type, right? How do you know this? Well, go here, associate type, iterator protocol. So you're returning iterator protocol. So this method returns an iterator protocol. And then let's go bottom, let's type, go click on it, iterator protocol. Iterator protocol. Click on it. You'll see that it contains the element, and then it contains a method called mutating function next returns self.element. So returns this element, which should be infer based on the value you play around with it. So in this case, the element, the value has been infer. The element has been infer based on you enter number 7, so it becomes int. Make it where it returns int value. Okay, int value here. We're talking about it, right? Generic protocol. In chapter, I believe it's chapter 7 or 8. So now let's try to conform that thing. Okay, here we go. What we're gonna do is we're gonna create a, let's call it countdown. So what you want to do is you want to create an object, and then you want to create a struct that what it do, you want to do for loop the countdown, so you can do 5, 4, 3, 2, 1, and then boom, something like that. So how to do that? Well, first of all, you're gonna have a countdown struct that confirms a sequence protocol. And if you remember, go to sequence protocol, you need to have something called make iterator function. You have to implement this. This is a required method, but the rest is not required. How do you know which one's required now? Well, I don't know. So what I do is go to documentation, take a look at, hey, which one's required. They tell you which one's required, and all you have to just copy what's required and use it, right? Again, this is API protocol written by someone else. So all we have to just follow their rules. So create this make iterator protocol, and then you have to return. I'm gonna call it like this way. Okay, just bear me a second. Make iterator, and I'm gonna create a struct, and then that struct called countdown iterator will confirm to. Just bear me for a second. Iterator protocol. Here we go. So I'm gonna return a countdown iterator. Again, remember correctly, this function should return something that confirms to that iterator protocol. Yeah, I'm gonna return it. And I'm gonna create an object with self in it. So that means this is an object, right? So this is initializer method. So I'm gonna provide an initialization method, and you're gonna enter self. So that means you're entering my countdown object injected into countdown iterator. So let's create a iterator protocol now. Here we go. Here we go. And then I'm gonna have an init method. So init, initialize it, so self countdown. So this is this is calling right here. This init method is happening right here, and then you're gonna call it self countdown equals countdown. That means we have to create a variable or constant self countdown, and then let's call it times. Going to be used to track the countdown later down the road. So we have a starting here. When you have 5, it's gonna be, when you run the for loop, you're gonna be 5, 4, 3, 2, 1, and boom, that's it. But I know right now so far it may seem very, very confusing. Just bear with me for a second. I'm gonna walk you through it slowly once we go through the entire code, okay? And then if you remember correctly, if you take a look at iterator protocol, it contains a required method called mutating func next. So this method, what it does is it needs to return some sort of value, but it's going to be an optional type. The element is defined based on the value you work with. If you enter string value, the element is going to be string value. If you work with int value, it's going to be int value, but it's going to return an optional type, just like above right here. We've done it before. It returns an optional type. So how to do that? Well, we just provide our own customization, custom implementation. I'm going to define int element here explicitly, and then this is what's going to happen. I'm just copy and paste this code because This is just the logic part. Let's call it let number. Next number is countdown start dot minus time. So let's say you're starting out with start as a 5. Okay. Right now the next number is 0. Right. Times is 0 right now. So next number should be 5. And then you enter that if next number is for a second, just ignore this second, and then you're gonna do times plus minus 1, return next number. So it's kind of repeating itself. So right now, when you call the next function again, the times becomes 1, so the next number becomes 4. When you run this function next again, the times becomes 2, right? And then next becomes 3, and then next becomes 2, 0, and 1. But you want to have a guard statement. What's happening is, with the next number reaches 0, you're going to return nil. Okay, we talked about guard statement. If it's false, run this nil block. If it's true, then don't do anything about this. Ignore this guard block. Okay, so now let's see what's happening. Let's try that. So create 3 to 1, and my count starting from 3. And then what you want to do, you want to create 3 to 1, and then you want to make an iterator now. A var iterator. Here we go. Okay, now as you know, iterator has that method called next method available, and what it does is returns the value of, you're working with the start value, so it becomes 2, 1, 0. So let's take a look at it. Iterator dot next, iterator dot next, iterator dot next. Let's take a look at the right side. Boom, 3, 2, 1. Okay, right there, and then see what happens. Nil. And again, you can create your own implementation. If you call this next, you can also have like return 10. So what's happening? It's only going to return 10 no matter what you do. All right. You can provide your own custom implementation with that. You can call it next. As long as you call it next, that's fine. But you can provide your own custom implementation for that. You talked about it before. Protocol is like a basketball coach. It tells you what to do, but they don't know how to dunk a basketball. You can do some windmill dunk. You can do back end dunk. I'm into basketball, so you can do your own fancy stuff on your own. Okay, so so now here comes what's happening. The magic happens. Again, my count 3 to 1, and then print count 3 to 1. So again, as I talked about this syntax is being transpiled, or probably, I'm not exactly sure if it's a transpiled or it's turned into machine code. I don't exactly know, but underneath what's happening is this code is converted into this way, and then they call this next method while let is happening until it hits nil value. Okay, so you now understand what makes for and loop possible and what for and loop converts into. That was it for this lesson. So I'm gonna review a little bit one more time, because I know this lesson was a little tough, and when I first learned about sequence, it was the toughest thing. Like out of entire chapter of course, I think sequence is harder than learning about closure back then. So again, I'm gonna do it again. So sequence, anything that has a method called for and loop, okay, confirms the sequence protocol. We talked about it, right? So that means array definitely confirms the sequence protocol. String confirms the sequence protocol. Okay, but anything that confirms the sequence protocol must have a method called make iterator function. Okay, and this make iterator function returns something, okay, an object that confirms that iterator protocol. Okay, cool. Okay, so we have something that, so we design our own struct that confirms the iterator protocol that is returned by the make iterator function, and then we provide our own custom logic here. And then anything that confirms the iterator protocol must have a mutating function called next. And again, the next, you can provide your own custom implementation. You can just return like 10 all the time, but you can do some more interesting stuff with it by providing your own custom logic to it, right? You use plus minus 1, so the number keep changing, and also the guard statement you use to return nil later down the road. Okay, so that's why you're able to use make iterator and then call this iterator next. So is it making sense? I mean, when you're first starting out, you thought like, oh, this is too much, but when you take a look at the bigger picture, hopefully things become much easier. I mean, I try my best to explain this concept. It's really it's a difficult one. I think I recorded about 5-6 times to make sure I can explain this well enough. But again, the best way actually to learn something about protocol is not from me. It's to go to documentation, and then go to documentation here, take a look at their examples and how they use it, and then just this example is driven from the documentation. Okay, so just copy their code and then see how they work, and then what kind of implementation we have to follow, and how the Apple engineer use that protocol in their own their default struct value, such as string or int. Okay, as long as you can do that, customization should be easy. Okay, so we covered the four so far. We covered equatable, comparable, sequence, and iterator protocol. Again, there are a lot more than just forks. In Swift, there are a lot more, right? You can talk about a lot more. So, for example, I'm just going to give you one of the things. One is expressible by string literal. Okay, so how is it possible that you are able to print, and you can do hello, as well as you can print 1 to 3, print and true? Right, this is string value, this is string type, this is int type, this is a boolean type. Because all this type, they conform to a protocol called expressible by string literal. Okay, it's converting into string value, and then you're printing out on the bottom here. Okay, that's what's happening. What's happening here? I don't exactly know, but it doesn't really matter. That's what's happening here. Because it confirms that string literal, you are able to express it on the bottom, print it out. Okay, that's it. That's what protocol does in Swift, and there are a lot more out there. And you probably don't need to use their protocol, because now the Swift you don't really need to learn protocol to become a good developer. But there are times you want to make sure you want to use your own custom protocol, such as for counting down. Yeah, you could do that. You can make your own protocol, but you don't have to. You can just make an array for it. But if you need something, you know what to do now. You just need to go here, take a look at some of the protocols, and then see how you can use them. Okay? See you guys in the next lesson, the very last lesson. And you guys come a long way. If you come this far, I'm very, very proud of you. Thank you very much. First, you've learned the hidden implementation that goes behind a for loop. To make types eligible for that magic, it has to confirm the sequence protocol that contains a required method, and that method returns an object that confirms to iterator protocol. Then the object that confirms the iterator protocol contains a required method called next, and that next method is called when you run the for loop. Just read the manual written by the Apple engineers and then follow them, and simply works. You really want to know how Swift works, you definitely want to learn about C++ and then go there how the language is made. But we don't have to. The purpose of this lesson is not to make you memorize. In fact, it's to understand that how the Apple engineers use protocol to scale and also provide great architecture by confirming to certain protocols. As long as you understand that part, now we developers are able to go to documentation, take a look at the protocol that are predefined by the Apple engineers, and simply use them. This is why learning about the fundamentals is the most important skill set being a developer. In the next lesson, you will learn how to execute Swift files without having to use Xcode application, and also send red marks on the left side. See you in the next lesson.